Today we're looking at solving systems of equations. That's what this unit's all about. And to start off, we're going to graph, okay? So first, a system of equations, you've probably seen this before, but it's simply a set of two or more equations that use the same variables, usually x and y, but it could be other variables. When you solve a system of equations, you're trying to find the values that would make every equation true. So for example, what x and y value would make each of these equations true? A general rule of thumb, how many ever variables you have, that's how many equations you need to be able to solve it completely, okay? We usually write these using braces. Here's just a couple examples down below you can look at. So, we're going to solve by graphing, and then as we move forward, we're going to look at some algebraic methods. So first of all, I want to just bring up Desmos here, and here's what I would encourage you to do. If you've got a graphing calculator, even if you do, I would encourage you to use Desmos.com, honestly, because it's going to be quicker and cleaner probably. So solve by graphing. Now if we were doing this by hand, we'd rearrange these, we'd probably put them in a slope-intercept form, right? Y equals, and graph them. And you know how to graph lines, that's not a big deal. But Desmos, just type them in, okay? 2x plus 3y. Here's a really cool thing. There's a lot of cool things about Desmos, but you don't need to rearrange the equation. It'll just graph it for you. Next one, 2x minus 7y equals negative 1. And I'm just using my keyboard here. You could also use this pad and bring that up if you want. Now, here it graphed the two lines for me. Now, here's really cool. Right there, you see the point of intersection, 3, 1. And so if you plug x equals 3 and y equals 1 into both those equations, it's going to be a true statement. And so the way that we would write our solution to this, if it was asking us, is actually as an ordered pair like that. That's the way I would like you to write it. So we'd write 3, 1. Again, that means x equals 3 and y equals 1. That was our, let me double check. I think that was, yeah, 3, 1 was our solution there. Okay, not too bad. So here I'd like you to try one. Now, I'm going to do it on Desmos to verify it, but I'd encourage you maybe just pause this video, bring up Desmos, and try this and see what you get. Let me go ahead and clear these out. I'll just type them in here. 5x plus 5y equals 15. There's our first equation. 6x minus 4y equals negative 12. Look how slick that is, nice and easy, and it looks like 0, 3 is the solution. Is that what you came up with? Hopefully. 0, 3 looks like our solution there. So let me just write that. So 0, 3 was our solution. Make that look like a 0. Not too bad. That's really what I want you to do today. Go to Desmos, graph them, look for solutions, understand what these things mean. As the lesson goes through, it's also going to talk about trend lines, scatter plots a little bit. Go through it, not too big a deal. I'm not thrilled with some of the questions, so I removed those from the practice assignment. Now, there is something else we want to talk about though. When lines are graphed, okay, we're just talking about lines right now, only 3 possibilities exist. Okay, those lines could intersect. If they do, we call that an independent system. That occurs when lines have different slopes. They have to cross somewhere, right? And maybe let me pause here. I would encourage you to write these down. Okay, take these notes in your notebook. A second possibility, they could coincide, meaning they're right on top of each other. We call that a dependent system. And that's when the exact same equations, okay, they might not look exactly the same at first, but if you simplify them, they're actually the exact same lines, so they're right on top of one another. In that case, you're going to have basically an infinite number of solutions to that system because every point on those lines is a solution. Whereas in the first one, independent, there's one exact point that intersects, one solution. Okay, and the other possibility is they are parallel lines. They never cross each other, right? And we call that an inconsistent system. There is no solution. There's no x and y that's true in both of those. And that occurs when those lines have the same slope but a different y-intercept, right? So they're just parallel lines together. And so, building on that, let's just look at these. Without graphing, classify the system. Now, it'd be easy to go graph these and look, wouldn't it? But I want you to understand the principle. So what are we looking for? Well, do they have different slopes, basically? So you could rearrange these if you want. But just looking at this fact, let's just rearrange them. Let's put them in slope-intercept form. So this would be y equals, right, if I just added my y over y equals x minus 5. And of course, y equals 2x minus 3. Now, all you're looking for is a different slope. So this is a independent system. Meaning, and they didn't ask me to find the solution, just classify it. It's independent. They're going to cross one place. It's going to have one solution. All right? How about these guys? Now they look different. Let's simplify them. I notice in this first one, I could divide, what, a 2 out of all of that? So let's divide a 2. So that would be 2x plus 4y equals negative 3. In the second one, let's just simplify as well a little bit. Looks like I could divide a 3 out. So 2x plus 4y equals negative 3. Notice anything? Hey, they're the exact same equation. I don't need to rearrange them to see that, do I? So this would be a dependent system. They're the exact same line. They're going to be right on top of each other. Now, let's look at the last one. This one, not much going on there. This one, notice, in fact, we'll go ahead and rearrange this, okay? So y equals negative 3x plus 5. And if I go ahead and take things over, so 5y equals negative 15x plus 2. Divide my 5 over, so y equals negative 3x plus 2/5. Here's what we're looking for. Exact same slope, right? Not the same line though, exact same slope. So those are parallel. Remember, we call that an inconsistent system. Okay, so you'll classify things a little bit in the lesson as well. All right, again, really encourage, if you haven't already, please utilize Desmo's awesome, totally free tool, and I think it'll really help you as we go through this lesson in this unit.